This lesson is on scientific notation. When dealing with very large or very small numbers, keeping track of the place value can be difficult. We're talking large numbers like the distance from Earth to the moon, or really small numbers like the size of an atom. For this reason, numbers such as these are often expressed in scientific notation. A number in scientific notation is written as a times 10 to the nth. So a is going to be a number times 10 to some power, either positive or negative. And a, so this is going to be where a is always going to be a number between 1 and 10, not including 10. So there's always going to be one digit in front of the decimal place, but it can't be 0. So it can be 1, 2, 3, 4, 5, 6, 7, 8, 9, point any other numbers after that. So a is a number that can be 1 through 10, not including 10. The other thing is that n is always an integer. This means a whole number that's either positive or negative. So a number in scientific notation is written as a times 10 to the nth, where a is greater than or equal to 1 but less than 10, and n is an integer. A number not in scientific notation is in standard form. It's in standard notation. This is what we usually see numbers. 1, 1000, 3600. These are all numbers that are written in standard notation. So we're first going to look at scientific to standard notation. And there's two important things to remember. This is when we're moving a number that's been given in scientific notation and putting it into our standard normal way we look at numbers. If n, that's the exponent, if n is greater than 0, we're going to move the decimal in a. So remember, we have a times 10 to the nth power. If this exponent of n is greater than 0, so it's a positive number, we're going to move the decimal in a to the right n places. So whatever the exponent is, if it's positive, we're going to move it to the right however many places it is. If n is less than 0, we're going to move the decimal in a to the left n places. This is going to make for a small number. The exponent is negative. It's not turning it into a negative number. It's just making it much smaller. Alright, so let's take a look at some examples. We have 3.26 times 10 to the 6. The first thing you want to look at is the exponent. Is the exponent positive or negative? If it's positive, just like we have a number line, we have 0, 1, 2, -1, -2. If it's positive, we're moving to the right. If it's negative, we move to the left. So this is a positive number, so we're going to move our decimal point 6 spaces to the left. So I'm going to write my number, and then I know my decimal spot starts here, and it's moving over 1, 2, 3, 4, 5, 6. So my new decimal spot's going to be here, and I can fill in the holes with zeros. Remember, to write this number like a normal number, we use every 3 from the decimal spot is a comma. So 1, 2, 3, comma, 1, 2, 3, comma. So our number is 3,260,000. And I recommend you rewrite the number afterwards so that it's clearly seen. Now looking at our second example, we have 1.02 times 10 to the -3. That exponent is a negative number, which means we're moving to the left 3 spaces. So I have 102 as my number. My decimal spot is here. So I'm going to be moving 1, 2, 3 spots to the left, and there's my new decimal space. Filling it in, we have a 0 here and a 0 here. And if I rewrite that number, I'm going to have 0.00102. You always want to include all of the numbers given, and then just move the decimal point to the left if it's a negative exponent, to the right if it's positive. Now we have going from standard notation to scientific. Technically, people say to just reverse the process. The first important thing to remember is that A has to be between 1 and 10. It can equal 1, but it cannot equal 10. The way I like to think about it is, if it's a large number, it's going to have a positive exponent. If it's a small number, it's going to have a negative exponent. The reason why I like thinking of it this way is it can get very confusing about which way to move the decimal. So if you just worry about finding A, so step 1 would be to find A, and then however many spots from the decimal spot in A to where the decimal place is now, and you'll see an example of this, then however many spots that it is the exponent. And again, if it's a large number, that number is positive. If it's a small number, and when I talk about large number and small number, I'm referring to A. So let's take a look at this. So we see here we have 23,400,000. Is this a large number or a small number? This is a really large number. So we know that we're going to have a positive exponent. All right, so step 1, I'm going to find A. Remember, A has to be between 1 and 10. So I know that my first number has to be 1 digit, so my decimal spot is going to be here. So my number is going to be 2.34. We include all of the numbers, don't round. And then we know it's going to be times 10 to a positive number. And now I don't need to worry about if I'm moving in this direction or if I'm moving in this direction. Either way, I'm counting from one decimal spot, the new decimal spot, to the old, or the old to the new. So 1, 2, 3, 4, 5, 6, 7. I've moved 7 decimal spaces. I know because it's a large number it's going to be positive, so 2.34 times 10 to the 7th. Looking at my second example, I see that it's a small number. It's a decimal less than 1. So I know that this is going to be a negative exponent. So my first step, again, find A. I'm looking for a number between 1 and 10. So I have the numbers 567. My new decimal is going to be after the 5. So 5.67 times 10, and as I said before, it's a small number, so it's going to be negative. And then it doesn't matter which direction I count, 1, 2, 3, 4. Or I can start here and go 1, 2, 3, 4. Either way, I know the exponent is going to be 4. So 5.67 times 10 to the negative 4th power. All right. I want you to pause the video and try these on your own. You're going to express each of these numbers that are in scientific notation. You're going to express them in standard notation. Okay, looking at this, we have 7.48 times 10 to the negative 3. If I have 748 and my decimal spot is here, I'm moving 3 to the left, so 1, 2, 3. I'm going to fill in my holes, and my new number is 0.00748. If you got that, very good. Now looking at my second number, I have 2.19. So 219, and I'm moving, because it's positive, 5 spots in the positive or to the right direction. So 1, 2, 3, 4, 5. I'm going to fill in my holes. I know my decimal spot is there. And if I rewrite that number using proper commas, I'm going to have 219,000. If you got that both answers correct, I think you understand how to express in standard notation. Alright, now I want you to pause the video again and try these two examples on your own. Okay, so you're expressing these numbers that are written in standard form now in scientific notation. Looking at the first one, we see it's a really small number, so we know it's going to have a negative exponent. Next, I want to find A. A has to be between 1 and 10, so I know my number is going to be 6.72 times 10 to the negative something power. Well, if here's my decimal point, 1, 2, 3, 4, 5, 6, 7. I know my exponent's going to be negative 7. So my answer is 6.72 times 10 to the negative 7th power. Looking at the second example, I know A is going to be 3.022. You want to include all of the numbers, times 10, and since it's a positive, it's a very large number, it's going to have a positive exponent. So counting, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my answer is 3.022 times 10 to the 12th. If you got both of these correct, then I think you have a strong understanding of scientific notation.